remember she helped us? We had to all it was like a homework.
We didn't write that. She did.
Alright, whatever. I don't know how we can't agree on if we've already designed the bio lab.
We kind of did, but we kind of did.
Yeah. Because she helped us because it wasn't going to like the I just wanted to come on, so we didn't technically do all the work.
Okay, so you didn't design one yet, fine. But it sounds like you probably have gone over the design criteria, which are the same for physics, but in practice they actually might be pretty darn different. Now, if you, I'll give you some paperwork out in a few minutes. So our first aspect is called defining the problem and selecting variables, right? So the problem would be like a research question that you are coming up with on your own. Now, for physics, you can't just have a simple yes-no research question. Can you do that for bio? Like, does yellow light hamper the productivity of soybeans? Like, you can't do that. Good. So you can't do simple yes-no questions for bio either. Fantastic. For physics, you have to be seeking to have a mathematical relationship between your dependent and independent variable. Okay, in bio, you probably don't have to do that. So you have two variables that you're trying to make a relationship with. It has to be a mathematical relationship. So all of your stuff has to be quantitative. You cannot have color, right? Color's not quantitative unless you're like recording a wavelength associated with that color. All right, so when you define your problem, you have to be trying to find a mathematical relationship between your two things. So your two things, where I'm using the terms, vaguely, now we'll get specific, the independent variable, right? That's the variable that you are changing, that you're manipulating. So earlier in class, I made reference to like dropping a ball and finding the bounce height. So the research question would be, what is the mathematical relationship between the height that I bounce the ball from and the height that it bounces to? The independent variable would be the height that you're dropping it from. Right? And then you would vary that. You'd maybe drop it from 10 centimeters and from like 10 meters, right? Whatever. That's your independent variable. Your dependent variable is then the thing that you're measuring that probably responds to the independent variable. So in my example, the dependent variable would be the bounce height, how high it bounces to. That has to be quantitative also. Both of these have to be quantitative, or else we can't make a graph and find a best fit line, and a max line, and a min line, and all that good stuff. Now, we also have other variables that need to be identified. Those are called control variables, and those are everything else that maybe would affect your dependent variable. So for instance, in my drop, like bouncing the ball one, gravity would affect the bounce height, maybe, right? So we want to control gravity. The temperature of the ball would probably control the bounce height, so we want to control the temperature. Now some of those things like gravity, yeah, you're laughing because it's controlled automatically, unless we do some trials here and then transfer to like a school in Colorado and do some trials there. But temperature, you're going to have to control, right? You can set the thermostat so that it doesn't change the temperature in the room. You can give 2 minutes in between bounces, because as you bounce the ball, it's going to heat up a little bit. So give 2 minutes so it can cool down, or maybe put it in the fridge for 2 minutes and let it reach an equilibrium temperature. So the controlled variables are everything else that might influence the dependent variable, but we have to control them or it would mask the effect that the independent variable are having. I'll get questions in a second. And then you do want to list all these variables like in a table to make it very explicit. Patrick?
So would you have to include gravity in that, or is that just assumed?
No, you shouldn't assume anything. Don't assume anything. I mean, worst case scenario, you're like, there is none. Best case scenario, the moderator is going to say, hey, wait a second, if I did this on the moon, it's going to bounce differently. Why didn't this person say that? Right? Maybe they're sending this to NASA to do this like on the space shuttle. Right? NASA does accept projects from students. Other questions about how this defining the problem and selecting variables applies to physics? Okay. Aspect 2 is on controlling your variables. So this is your procedure. This is the steps that you're going to take to properly control all this stuff, right? Be very explicit. Don't assume that somebody would do it the same way as you, right? If you're measuring the height that you're dropping the ball from, how are you measuring it? What are you measuring it with? Are you using a meter stick, right? What part of the ball are you measuring to? The bottom of the ball, the top of the ball, the middle of the ball, right? Be very explicit. Say how you're going to drop the ball. Say, I'm going to have one hand, I'm going to hold it from above, and I'm going to open my hand so that my fingers move like outward from the center of my hand. We talk about all of that level of detail. Follow-up questions on controlling each of these things that you're talking about in aspect 1. All right, and then finally, aspect 3 should be the easiest if you bother to take notes or look back at this video as you design labs. It's developing a method for the collection of relevant data. So we use what we refer to as the rule of 5s here. The rule of 5s helps us remember that we do want at least 5 trials for each value of your independent variable. Right, so for each height that I drop the ball from, I want to do at least 5 trials from that height, or at least 4 replicates of that first trial. And then the other part of the rule of 5s is I want at least a range of 5 between my smallest value of the independent variable and my largest value of the independent variable. So for these drop heights, right, if that's really the investigation that I'm designing, maybe, so the drop height, maybe I do want to do 10 centimeters is pretty low, but maybe I want to do that, right, as my smallest value of my independent variable. I have to at least go up to 50 centimeters for my largest height. I would go higher than that. I'd go as high as I could reach. I'd go 2 meters, right? But I have to at least have a range of 5 in between those. And then you don't have to do, so let's say that I do better than the rule of 5. Let's say I do go up to 2 meters or 200 centimeters. You don't have to do an even spread, right? You could do 10, you know, maybe you want to do 4, maybe you want to do 30 centimeters because you have a ruler that goes up to 30 centimeters, that's fine. Maybe you want to do 100 centimeters, 150, whatever. I mean, you could make it even if you want, but there's no rule that says it has to be an even increment between your trials. That's pretty much all that I have for you on the design criteria. Other questions before I ask you to assess a lab that was designed by one of the seniors? Yeah, Patrick.
Do you want us to do the trials like we did last year, where you do 1 trial for like every value, and then
Yeah, I mean, so that's something that it could crop up in aspect 2 of properly controlling your variables. So Patrick's remembering that last year I yelled at you if you did like all of your 10 centimeter trials, and then all of your 30, and then all of your 200. And the reason that I didn't like that is, let's say that your ball does change temperature, right? Like you don't bring it into equilibrium with the room each time you do it. The ball's going to get hotter and hotter, right? Bless you. Each time that you do it, that will change how high it bounces to. And that's going to like give you artificial results that the 200 centimeter will proportionally bounce higher than the 10 centimeter, when it just isn't true. It's not going to help answer your research questions because of this thing that you didn't properly control. If you cycle through, that will help you identify if you had a problem in controlling something, and it gives you more to write about in your conclusion. So yes, I absolutely want you to cycle through. However, that probably wouldn't end up costing you anything in the design, like marks. Other issues before I have you evaluate somebody else's design. All right, so the investigation that I have for you, I don't think this is one that I already gave you to assess the data collecting or the concluding, but it's possible that I did. You do not have to look through the data on this, right? You should look through the research question and the table that tells you what all the variables are and the procedure. And then for each of these 3 aspects, give it a complete, partial, or not at all. What I'll loan you, I prefer not to give it to you, but if you don't have it, keep it. I'll give you like the grid that has the like descriptors of complete, partial, and not at all. But see if you have your own first. You all should have this already. So I'm actually going to hold off a minute or 2 before I give you that.